All right, guys. I'm just realizing that the 7.4 practice sheet that I gave out is actually a little bit different than the answer key that goes along with it. Only the only thing that's wrong with it is that these last two problems on the first side are not provided on the answer key. So I just thought we could do these together, and that'd be that. So let's do this one. Here's your thermochemical equation. We've got 1 mole of nitrogen combining with 3 moles of hydrogen to make 2 moles of ammonia. This is an exothermic reaction. Delta H is a negative 91.8 kilojoules. We want to know how much energy is produced when 222.4 grams of nitrogen reacts. So here, what we do know for sure is that when 1 mole of nitrogen reacts, we should get 91.8 kilojoules. We just have to basically figure out how many moles this is and then compare it against the delta H. So here's how we set this up. We're going to start with 222.4 grams of N2. This is the dimensional analysis. So the first thing we want to do is convert that into moles. So 1 mole of nitrogen gas. Let's see, nitrogen is 14.01 times that by 2, 28.02, 02 grams. Okay, and then here we're going to use the coefficient from nitrogen, which is a 1. And then we're going to use the positive value, the absolute value of this delta H right here, 91.8 kilojoules. Okay, that's how it sets up for a problem like this. So let's just do the math here. Good. 728.6 kilojoules. Okay. And we've made the assumption here that nitrogen is the limiting reactant, and we just have to do that because it doesn't mention how much hydrogen is there, so we'll just assume that it's in excess. All right. All right, this next one is a really interesting reaction. It's an endothermic reaction, and we know that because of the positive delta H here. Nitrogen gas, oxygen gas, combining to form nitrogen monoxide. That's cool. So if we have, it looks like we have endless supplies of both of our reactants, but we only have 558 kilojoules of energy. What mass of nitrogen monoxide can be made? Okay, so this is a little different type of problem, and we're going to set it up similarly, but it's going to be a tad different. So we're going to start with our energy value here. So 558 kilojoules, and we're still going to do dimensional analysis here, but in the middle of this dimensional analysis, this is where our energy to mole ratio is going to go. All right, so we're all about crossing off units here. So we want to put our delta H down here. This is our 180.6 kilojoules, and then the coefficient of the compound in question is going to go right here. So because we're asking about nitrogen monoxide, we're going to use that too. Okay, and then we're going to convert everything into grams, because remember that this is a mole unit right here. Sometimes we don't put the mole there, but we just need to convert this number of moles into grams. So we are going to do the conversion here. 1 mole of nitrogen monoxide, 1 nitrogen and 1 that's 30.01 grams per mole. Okay, so we'll just calculate across here. 558 times 2 times 1 divided by 185. So this is 185 kilojoules of energy are, oh no, this is not kilojoules. This is grams of nitrogen monoxide are produced. Okay, so there you go. There's those two problems that were not on the answer key, but now You have the means to do those, all right?